Hey everybody. So welcome to the last type of conic section, the parabola. So you may think you already know everything you need to know about parabolas, but that's really only for up and down parabolas. What if we turn a parabola to the left or to the right? So on my screen here on the right, I have a graph of a parabola opening upward. Over here on the left is its equation, y equals x squared, not moving to the left or right, not moving up or down. If I wanted to flip that over, all I'd have to do is put a negative in front of the x squared, and then it's still centered at the origin 0, 0, but opening downward, thanks to that translation rule where you throw a negative in front and that creates a reflection. So if I graph x equals y squared, so now I've put my square on the opposite term or the opposite variable, the y instead of the x. Well, y is still positive, so that means it's going to open to the right. And then can you guess what would happen if I put a negative in front of the y squared? You got it. It's going to open it to the left. So if you have x squared, it's going to open either up or down. Up if that x squared term is positive, down if the x squared term is negative. If you have x equals y squared, it's going to open to the right if y squared is positive. It's going to open to the left if y squared is negative. Now, I personally think that's a little bit confusing. You know, the y axis runs up and down, so why wouldn't it be opening up and down? Well, the deal is it has to do with how many solutions you have. So I've plotted a couple of purple points over here. Notice that I get two x's for every one y value. The point over 2 up 4 is on that parabola, as is the point negative 2, 4. So every time I go y equals x squared, if I plug in one x, I'm going to get out two different y values. Or notice that I have two x's in the same y. So similarly, if I plot over 4 up to and over 4 down to, those points lay on the parabola that opens to the right, or the x equals y squared. So two different y values for every one x value. So it's kind of counterintuitive, kind of opposite of what you would think. All right, so here's another example of a parabola. This parabola is going to be opening upward, and as you can see from its equation over here on the left, the parabola has been shifted to the right one and down two. The number that's in front of the x squared part is positive, so it opens upward. There are two other features of this conic section definition parabola, and that is the focus and the directrix. The focus is a point inside of the parabola, and the directrix is a line outside of the parabola. The directrix will never run through the parabola, but it will be perpendicular to the axis of symmetry, which you remember from our quadratic equation chapter. So the cool thing about the focus and the directrix is that they are equidistant from any point on your parabola. So we can see pretty clearly that the focus is like, just a little over 1 units above the vertex, and the directrix is a line that's running horizontal about a little over 1 units below the vertex of this parabola. So the focus will always be inside the parabola, or the parabola will always wrap around the focus, and the directrix is outside. So one more time, the cool relationship between focus and directrix is that if you go from the focus to a point on the parabola, and then from that same point straight down to the directrix, so that this would be a 90-degree angle, those two lengths will always be equal. So I can go from here to there and then straight down, and that's going to be the same amount of distance. It's hard to see on this screen, but you got to just trust me. It's really the way it works. Here's another parabola. This time, this parabola opens to the left. Could you have figured that out from this equation? X equals a negative y squared. X equals negative y squared. Also, I'm not going to shift at all to the left or to the right, but I am going to shift up too. So notice where my vertex is. So that's just the translation rules again. Nothing left or right, but up to. Okay, and then to plot my focus needs to be inside this parabola. And I'm not going to bore you with the math of how you're going to come up with that focus. I don't care. You don't need to know. If you really want to know, then, I don't know, call me or something. And then the directrix is also going to be on my graph, but this time it's going to run vertical. The distance from the vertex to the focus will be the same as the distance from the vertex to the directrix. Again, how I came up with this information right here which as you can see is the same as, in my focus and my directrix, they both contain that part. Not something you need to be concerned with. If we were all together at school, we would be doing this really cool activity that I have. You get to use a compass and some butcher paper and a ruler, and oh my gosh, so cool. I went to a whole like weekend long seminar on teaching conic sections a few years ago. My favorite thing. All right, last example. Here I have another parabola opening downward. Could you have told that or could you have figured that out from the equation? I bet you could have. You've got y equals a negative x squared. So negative x squared, you've known about that for years. Negative x squared is a parabola opening downward. No shifts left or right, but a shift up 2 again. So there's my vertex. My focus will be inside the parabola, so somewhere over here. And then my directrix will be outside of the parabola. Up here, it's going to be a horizontal line. And then that's really all I need you to know about a parabola is what's the direction of the opening? Like where in general would you find the focus? Like is the focus going to be in the first quadrant or the second quadrant or the third or the fourth? And that all depends on where your vertex is located and how your parabola opens. The other thing that you might need to be able to tell me is where is the directrix? Is it horizontal? Is it vertical? Will it be to the right or to the left of the vertex? Would it be up or above or below the vertex? So that's all I have to say about that. The next thing I need you to do is look at a quick multiple choice assignment where you're going to tell me the direction of the opening. And then I need you to copy some notes that summarize all of the conic sections. All right, thanks everybody.